Welcome to today's video on regression analysis. In regression analysis, when we have two variables like x and y and there is a significant correlation between the two variables, for a given value of x, we will be able to find out the value of y, where x is the independent variable which the experimenter can manipulate and y is the dependent variable. In linear regression, where there is a linear relationship between the two variables, we can find the best line that can help us to predict y from x. In simple linear regression, we will have one independent variable, whereas in multiple linear regression, we may involve more than one independent variables. Sometimes the relationship may also be non-linear. So today we will see how to solve using normal equations. So we have a problem here. We have x and y variables and we have to find out the regression equation and see what will be the value of y when x is equal to 150. So, for this, the regression equation is given by y is equal to a plus bx, where b is the slope and a is the y-intercept. Similar to the straight line equation in algebra, y is equal to mx plus c. Now, for a given value of x, if we have to find out the value of y, we should know the values of a and b. B is the slope, A is the y-intercept. So to find out, we have two normal equations which we have to solve, and it is given by the formula sigma y is equal to Na plus B sigma x, and sigma xy is equal to A sigma x plus B sigma x square, where n is the sample size. So it is evident that we have to find out the value of sigma y, sigma x, sigma xy and sigma x square. So here we have totaled up the values of x and we have found out the sum, values of y and we have the sum, values of x square, values of xy, and we have the summation of all these terms. Now we have to solve it like we solve the simultaneous equation. So we have two equations here. Sigma y is 400. So 400 is equal to sample size is n, which is 5. So 5a plus b sigma x. So 210 into b. The second equation, sigma xy, is 19,900 is equal to a sigma x. Sigma x is 210, so 210a plus b sigma x square. This is 12,100 into b. So we have two equations. Now to solve this, we have to eliminate one, only then we can do it. So if we multiply the first equation by 42, so that 5a becomes 210a, we can cancel this when we subtract it. So we are writing the second equation first. 19,900 is equal to 210a plus 12,100b. And when we multiply this equation by 42, we get 400 into 42, 16,800. 5 into 42, 210a, and 210 into 42, 8820b. So now when you subtract, we get 3,100. 210a, 210a gets cancelled, is equal to 3280b. So the value of b is 0.945. So now that we know the value of b, we can find out the value of a. When we substitute it in this simple equation itself, we need not go to the multiplied version. So here 400 is equal to 5a plus 210. Value of b is 0.945. So when we solve this, we get the value as a is equal to 40.31. Now, regression equation y is equal to a plus bx. A is 40.31, b is 0.94. So, now the value of x given in this question is 150. So, when multiplied by 150, we get the value of y as 181.52. So, for a given value of x, we have found out the value of y. This can be solved using the data analysis pack. So in the data analysis pack, We have to choose a regression. So we have to feed in our y range and x range. This is the value of y. Then choose the value of x. Confidence level is 95% and we can get the result in a new worksheet. So when we click on OK, this is how we get the result. So we get the complete summary of the full analysis done. But the 2 points of interest for us are these two terms. So when you see, the slope is 0.94 and the intercept is 40.3. So when we are writing it as y is equal to, it will be 0.94 is the slope. So you can put it as 0.94 into x plus 40.31. So this we directly get the straight line equation. So now, if for a known value of x, we substitute, we can get the value of y. This is the same result that we got when we did regression. We got it as 40.31 plus 0.94x. So here also it is 40.31 plus 0.94x. So out of this entire result, these two terms are important for us to get the straight line equation. Thank you.